Hey guys, welcome to your next video on systems of equations and inequalities. In this video, we're going to learn about solving linear quadratic systems of equations. Sometimes when we look at a system, the graphs themselves don't have to be linear. We could have some sort of a curved graph, and we're going to specifically take a look at quadratic graphs in this lesson. So our learning target is I can solve nonlinear systems of equations and inequalities using graphing technology. Specifically in this video, we're going to be looking at systems of equations. In the next video, we'll look at systems of inequalities. So let's go with systems of nonlinear equations. Here we go. Okay, looking at this first problem, it says to solve each system by graphing. If we look at our first equation, you'll notice that the first one has a highest exponent of 2. That means this is a quadratic equation. And the second one is a linear equation. We're going to let our graphing calculator assist us in graphing these two functions and then finding the intersections. So let's take a look at our graphing calculator. Okay, so I've started by clearing my RAM, and what I would like for you to do, and with me, go to the y equals screen. Anytime we want to type in a function to graph, we're going to go to y equals. Our first function we're going to graph is the quadratic function, negative x squared plus 5x plus 6, so enter that beside y1, and arrow down. Beside y2, we're going to type in x plus 6. Reminder, your x button is right here beside the alpha key, and your negative button is on the bottom row. Okay, so your screen should look like this. Now if we push graph, we should see a parabola. There's our quadratic function, and a line. There's our linear function. I'm looking at this and saying, okay, first of all, I know this is going to have two solutions because I see that we're going to intersect 2 times. The solution to a system is where the graphs intersect. It's a little hard to see this solution up in this corner here, so I'm going to adjust my window, my pushing window, and I'm going to go higher. So I'm adjusting the y maximum. 10 was almost high enough, so I'm just going to change that to 15. Push graph, and let's take a second look. So there's my parabola, there's my line, and I can very clearly see there are 2 intersection points. I can calculate those intersection points on the calculator by pushing second trace and choosing intersect. We've done this before. Now it starts to ask questions. Now in the past we just hit enter, 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 and it found those intersections for us. Well, that's going to work just fine because I'm right here close to the first intersection. So I'm just going to enter, enter, enter for the first intersection is at 0, 6. So I'm going to jot that down. One of my intersections is at 0, 6. Okay, but I'm going to have to find a second intersection because they're also intersecting here. So watch carefully. Again, we're going to go to second trace. And we're going to choose intersect, number 5. But this time I want to move my cursor till it's closer to where those are intersecting. Enter for the first curve, enter for the second curve, and enter for my guess. That intersection is at the order pair 4, 10. So that's another intersection at 4, 10. All right. So those are my 2 solutions to the system. If we actually have to graph by hand, I want to show you how awesome this other feature is on your calculator. Do you see right above the graph screen there's a blue word? And that word says table. I don't know if it's going to focus for me. It says table. So if you'll push second graph, it takes us to a table of values. If you'll remember, in y1, we typed our quadratic functions. Our quadratic function. So that tells me my quadratic function, I'm going to graph with red. I can plot a point at 0, 6, 2, 3, 4, 5, 6. I could plot a point at 1, 10, at 1, 7, 8, 9, 10. I could plot a point at 2, 12. I could plot a point at 3, 12. I could plot a point at 410. Notice the pattern here. I could plot a point at 5, 6. I could plot a point at 6, 0. And if I were to scroll up one place, I've got a point at -1, 0. This gives me a really good idea of how that graph of my parabola behaves. One thing I will mention is it kind of looks like the parabola is level here at the top because those 2 points were the same at the same height. But I will tell you that a parabola is always curved. So it doesn't have a flat top. It kind of curves up a little higher. Then what was that value? Was that was 12. So it goes up a little higher than 12, and actually the maximum point is 12 1/4. But then when we connect, I try to show that it's actually curving up above those points and then it's crossing through. Please forgive me graphing with a stylus. It's kind of a disaster. Okay, but we're also going to graph our line, and I'll graph the linear function in blue. So if we look on our calculator screen, you'll see x here and y2. We typed our linear function in y2 when we typed it in. So that means I'm going to take my x coordinate from here, y coordinate from here, and plot the points. So I've got a point at -1, 5. 1, 2, 3, 4, 5. I've got a point at 0, 6. And there, that shows my intersection. I've got a point at 1, 7. I've got a point at 2, 8, and you guys probably see the pattern going on here. We can continue that pattern and then connect our points with a straight line. Hopefully your graphs look better than mine. Pencils are better than styluses. Okay, so what we were wanting to find were these points here. These 2 points where those graphs intersect. But how amazing is it that you can use your calculator and push second graph to take you to the table, and you can take a specific look at points that are on that line. By the way, we could have graphed that line another way. We could have said, oh, the y-intercept is +6, plot a point at 6. Oh, the slope of that line is +1, so from there we rise 1, run 1, rise 1, run 1, rise 1, run 1. Some of you probably remember graphing that way, but your graphing calculator is always there to lend a hand to you if you're struggling with how to graph something. So again, let me talk you through these buttons here. The y equals button is where we type in the functions. The graph button is where we view the graph. That's also where we pushed second trace to go to calculate second trace, and that's where we calculated intersections. That was under the graph button. The window button is where we adjusted the window to be higher so we could see the whole graph. And if you push second graph, that takes you to the table of values for those specific functions. Amazing. Okay, let's go to the second example. So for my second example, I'm just going to graph the system on the calculator and find the solution. So I've cleared the RAM. And I'm going to go to my y equals button, and I'm going to type in these 2 functions, -x² minus x plus 6, and the second one is x plus 3. So we type each of those in the y equals screen. Next, let's take a look at the graph. There's my parabola, and there's my line. I can view the intersections very easily here. How many solutions is this system going to have? Anybody know? 2? Yes, 2 solutions. 1 solution here, 1 solution here. It's where the 2 graphs, the parabola and the line, intersect each other. And we're going to let our calculator tell us those intersections. Push second trace, choose number 5, and I'm going to move to where I believe that first intersection is. I'm actually going to do the one on the right first. Enter, enter, enter. That intersection is at the point 1, 4. I'm going to calculate the second intersection by pushing second trace, choose intersect. I'm going to move my blinking cursor over close to that intersection and enter 3 times. And that second intersection point is at -3, 0. So the 2 solutions to this system of equations are 1, 4 and negative 3, 0. Awesome. Okay, third example. I've already cleared the RAM. I'm going to go straight to y equals. I'm going to type in the two equations. Negative x squared minus 3x plus 10. And in y2, I have x plus 5. Go to the graph. And again, we're going to be looking for where these are intersecting. Looks like they're intersecting how many times? 1, 2 times. So I'm going to push second trace, go to intersect, and let's take a look. Let's see, blinking cursor, enter, enter, enter. My intersection here is at 1, 6. I'm going to write that down as one solution. I still need to find the second solution. So I'm again going to go to second, trace, choose intersect, and I'm going to arrow left. It's kind of out of the viewing. There it is. It went way up off the screen. If I just keep pushing left, it comes back. And I'm going to hit enter 3 times, and my intersection here is at negative 5, 0. So my two solutions to this system of equations are 1, 6 and negative 5, 0. I bet you're liking this. Let's go to the next example. So I've cleared my RAM again. I'm going to go to y equals to type these in. The first one is x squared minus x plus 3. The second equation is negative 2x plus 5. I'm going to push the graph button, graph the functions. There's my parabola. There's my line. It looks like it's intersecting 2 places. I'm going to calculate the intersections using second trace, intersect, and here's my blinking cursor. I'm going to move it over to this one first. Enter 3 times. Intersection is at 1, 3. And I want to find the other intersection by pushing second trace, choose intersect. I'm going to arrow left all the way up to this other intersection, enter 3 times, and that intersection is at negative 2, 9. So the two solutions to this system of equations are 1, 3 and negative 2, 9. Do you think that we always have to have two solutions when we're graphing a parabola and a line? What do you think? Do we always have to have two solutions or two intersections? Okay, we're going to keep going and we're going to see what happens. And we're going to graph, go to y equals. First one is negative x squared plus 2x plus 1. Second equation is 2x plus 1. Push graph. Here comes the parabola. And here is the line. So what do you think? Are a parabola and a line always going to cross in 2 places? Can you tell? Zoom in the camera. It's a little hard to see. Maybe we could zoom our window in a little bit to kind of look at this area and see, is it crossing once or just crossing twice? So I'm going to push window. And I don't want to go all the way up to 10. I'm going to maybe cut this back everywhere. Negative 5 to positive 5, negative 5 to positive 5. That should automatically zoom in closer on the intersection so that I can take a closer, more careful look. Yeah, I don't think that those are intersecting 2 times. It looks like they're just touching. We would say that this line is tangent, new word. This line is tangent to the parabola. That means it's only touching it at that one point, like barely touching it. So we're going to calculate the intersection. Second trace, choose intersect, enter 3 times, and that intersection is at the point 0, 1. So back to the question. Do you think that a linear and quadratic system of equations has to intersect 2 times? No. Do you think that they have to intersect at all? We're going to keep going and see what happens. Okay, so again, I've cleared the RAM. I'm going to go to y equals and type in my two equations. X squared minus 2x plus 1 and x minus 3. Type them both in, push graph, and there's my parabola. Here comes my line. Uh-oh. By definition, the solution of a system is the point or points where the graphs intersect. Where are these graphs intersecting? You're right. They don't intersect. They don't intersect at any point. This line continues forever. This parabola continues forever, but this is going up and this is going in these directions, this way, and they're never, ever, ever going to intersect. So it is possible to say that there is no solution to the system. Will we call these parallel lines? No. That's not a line. That's a parabola. That's a line. We wouldn't call them parallel. We would just say that the two graphs never touch. They never intersect. Therefore, there are no solutions at all to this system of linear, to this linear and quadratic system. There are no solutions. So let's read our learning target again. It says, I can solve nonlinear systems of equations and inequalities using graphing technology. We didn't look at inequalities today. We just looked at systems of equations only. So systems of equations. We're not looking at inequalities yet, but we did learn how to find the solution to a system of equations where the two equations are nonlinear. Using our graphing technology, we're just looking for intersection points. We learned that with a quadratic and a linear system, we could have two solutions where they intersect twice. We could have one solution where they only intersect at one point at a tangent point, or there could be no solutions because the two graphs don't intersect at all. So I hope that this helps you. I hope you feel like you learned something new, and good luck with your assignment.